Hello students, I am Assistant Professor Vishakha Kadam from Professor Sambhajirao Kadam College, Deur. Today's lecture is for B.Sc. Part 2. From this lecture, we can start our syllabus of Semester 3rd, Paper 5, Real Analysis first. Now, our first chapter is Sets and Functions, and this is our first lecture. So, firstly we see the definition of set. A set is well-defined collection of objects taken as a whole. Sets are usually denoted by capital letters, that is capital A, capital B, capital C, etc. If X is an element of set S, then we can write as X belongs to S. And if an object Y is not an element of set S, then we can write as Y does not belongs to S. For example, capital N is equal to set 1, 2, 3 up to so on. Next we see the revision of set. In this, firstly we see the concept of finite set. If we start counting the numbers of elements in a given set, and if this process of counting comes to an end at some stage, then the set is said to be a finite set. Second, infinite set. If this process of counting does not stop at any stage, then it is called as infinite set. Next we see the methods of specifying the sets. The first method is roster method. This method, also called as method of list. If the number of elements in a set is small, then it is possible and convenient to list all of the elements. The elements of sets are listed one by placing commas between them and are enclosed between curly brackets. For example, capital X is equal to set 2, 4, 6, 12. The next method is set Boolean method. If there is a large number of elements in a set, then listing all of the elements is inconvenient. In such cases, we denote the set by starting a common property, which is unique to them. We describe the set as set small x such that x has that property. For example, capital A is equal to set A, E, I, O, U. Then by using set Boolean method, capital A is equal to set x such that x is a vowels in English alphabet. Then we see the concept of Singleton set. A set containing exactly one element is called as Singleton set. For example, capital A is equal to set 6. In this set, only one element is present. Therefore, it is called as Singleton set. The next point is null set or empty set. A set having no element in it is called as null set or empty set. It is denoted by Greek letter phi or curly brackets. For example, capital A is equal to set x belongs to capital R such that x square is equal to -9. The next concept is subset of set. A set capital A is said to be a subset of capital B if every element of A is also an element of B. That is, if x belongs to A, then x belongs to B. This is denoted by A is a subset of B. Here we can see the one more note. Empty set phi is a subset of every set, and every set is a subset of itself. The next point is proper subset. If every element of set A is an element of set B, and B contains at least one element which is not in A, then A is said to be a proper subset of B. For example, A is equal to set 2, 3, 4 and B is equal to set 1, 2, 3, 4. Then A is a proper subset of B. The next concept is power set. Let capital A be a set. Then the set of all subsets of capital A is called as power set of A, denoted by capital P of A. For example, if A is equal to set A, B, then power set of capital A is the set of singleton set A, singleton set B, phi, set A, B. The next point is equality of sets. Here we see the definition of equality of set. That is, two sets capital A and B are said to be equal if they have same elements. In other words, if A is a subset of B and B is a subset of A, then capital A and capital B are equal sets and we can write as A is equal to B. For example, A is equal to set 3, 4 and B is equal to set x belongs to capital R such that x square minus 7x plus 12 is equal to 0. Then it can be easily observed that A is equal to B. The last point is universal set. In any application of set theory, the sets under consideration are regarded as the subsets of fixed set. Such a set is called as universal set, which is denoted by capital U or capital X. Thank you.